All right, for one bell ringer. Number one, write a function g of x that represents f of x after being simplified. Question for you. Can I simplify about this by going, oh, I got 14s right there. I can just eliminate those. And I got x squareds. I can eliminate those. G of x, let's see, g would equal, and these negatives can cancel. And these x's can cancel. It's 5 over 9. What do you think? Good math, bad math?
Yeah.
That's terrible math. Terrible, terrible math. So whatever g of x is, it's not that. So what you have to do, what we learned earlier in the year, is you have to factor. So if you're going to try to cancel things, you can't cancel what we call terms. Terms are things that add and subtract. You cannot cancel terms like that. But what I can do is cancel factors. So I gave you a technique earlier in the year. It was if you have something in the form of ax squared plus bx plus c, I said let's use x method. Where we do a times c up top, the value b on the bottom, and then we look for two factors, m and n, such that they multiply to be a times c and they add to be b. So that's what I'm going to do here, where this is a is 1, this is b, and this is c. So I'll do the numerator first. So I'm asking myself, what are factors of a times c, which is 1 times negative 14, that add up to the value of b, which is negative 5. So we're looking for two numbers that multiply to be negative 14, but add to be negative 5. So to help you out, I'll do a little t-chart here. Factors of 14, I'll get the negative in a second, but just the number 14 itself would be 1 and 14 and 2 and 7. Which pair could be combined to create a negative 5?
2 and 7.
2 and 7, very good. So 2 and 7, how do I make that a negative 5?
You make 7 negative.
So 2 minus 7, I agree with you. So we're going to say this is 2 and this is negative 7. So those are my numbers. So what we do with the numerator here is we're going to say that f of x is the same thing as x plus 2 times x minus 7. That numerator is equal to this numerator here. We factor that, and I skipped a step there. If you remember, you take your a term and you split the power. So I take this term and I split the power, and that's where I got this x and x from, and this is the 2 and the negative 7. So that's how that put together. Now we do the same thing in the denominator. So we're going to roll this back. This time we're going to say my a is this one, my b is negative 9, and my c is 14. So I'm looking for factors of 14, because that's a times c, that add up to the value of negative 9. And we'll have the same chart. So which one could give me a negative 9? Would it be the 1 and 14 or the 2 and 7? How can I get a negative 9?
You can't.
We can get a 9.
2 negative.
Ah, there you go, Josue. So a 2 and a 7 give me 9, positive. To get a negative 9, I need them both to be negative. So it's a negative 2 and a negative 9, negative 7, I'm sorry. Question, do two negatives, when you multiply, give you a positive?
Yes. 2
negatives make a positive, so we're good there. And when you combine them, negative 2, negative 7, it's kind of like saying I owe Josue $2, I owe Jose $7. I owe a total of $9. So this works. So when you put these in parentheses, we have an x minus 2 and an x minus 7. And now I can do the problem as it says. G needs to be f of x after being simplified. And so you can now simplify it. This is in factored form, whereas this was standard form. You cannot cancel terms. Standard form is terms, which is adding and subtracting. This is factored form, and you can cancel identical factors. So mathematically, what we determine is the x minus 7s can be canceled out. And so the remaining would be the g of x. So we'll say g of x equals x plus 2 over x minus 2. I forgot to tell you, this is lesson 4.1. So if you go to, let's just open it up from scratch, chapter 4, We go open up lesson 4.1. We are doing, this is the number 3. Submit your answers to the bell ringers, guided practice, and release ACP questions. That's what I'm doing right here. And let me get this in a size screen where you can see what you need to see. I'm doing number 1 here. So g of x would be the simplified portion. And you click it from there. So if you don't have that open, you might want to do so now. Okay, that's our solution here. Number 2, what is the domain of f of x? So I'm going to help you out by graph. I could tell you algebraically. If you remember your domain rules for algebra, there are 3 things you can't do for domain. That'll break up a domain for being all reals. So the domain rules, number 1, you cannot divide by 0. You cannot divide by 0. Number 2, you can't have a negative square root. So x is going to be greater than or equal to 0. Or number 3, a logarithm must be positive. For this problem here, f, I'm dealing with division. And so you just say you can't divide by 0. So x cannot be the values where I get 0 in the denominator. So on this one, algebraically speaking, here's my domain, is that x cannot give me 0 for either one of these 2. So x cannot be positive 2, x cannot be positive 7. Those are the values that x cannot be 2 or 7. But it could be all reals other than that. So you'll see here, I'll show it graphically in a second. It's going to be all reals except for those 2 values. Those are the only 2 values that it cannot be, wherever you'd be dividing by 0. If that's a 2, 2 minus 2 is 0. If that's a 7, 7 minus 7 is 0. Okay, so let's check it out. Those are going to be the 2 breaks. So I'm going to go to Desmos here. X squared minus 5x minus 14 over x squared minus 9x plus 14. That was our equation. I'm going to hit the table. I'm going to hit that settings and then convert to table. And it'll show us the values that's undefined are the breaks. We have a break at 2, just like I said we would. And if I type in a 7 here, you see there's also a break at 7. So the domain, as you see it, it's all reals except for 2 and 7. 2, and if I click this graph, it should go white circled at 7, if I can get it right at 7. It's not cooperating. Let me try zooming in a little bit. There it is. Boom. See that white circle? That means the graph doesn't exist there. So we are correct. It has 2 breaks, 2 and 7. By the way, you could rewrite this. That's called using inequalities. You could rewrite your answer in interval notation, and to say all reals but 2 and 7, you would say it goes from negative infinity to positive 2, union 2 to 7, union 7 to infinity. This means the graph exists everywhere except for those points because it's a parenthesis and it does not equal a parenthesis. So this means all reals except for 2 and 7. That's an interval notation there. This is inequalities. Let's see, which way did they want the answer? Number 2, it wants it as interval notation. All right, number 3. What statements describe the discontinuities? Okay, so for our breaks, if you remember, if you cancel something out, there's another name for cancel out. It starts with the R, rhymes with removable. It's a removable. So we have a removable at 7. And what do you call, what's a synonym for if something stays forever?
Infinite.
Infinite. So I have infinite here, removable there. That's the algebra way of doing it. The break at 2 is an infinite discontinuity. The break at 7 is removable because we could cancel it. And if you remember inside lies, that's why you'd have to solve for x. That's why the sign switched on both of these and it became the opposite, or a liar. It's because you had to solve. You'd say set it equal to 0 and then add the 2 over it. That's why it became a positive 2. This became a positive 7. Okay, that's the algebra. Let's check the visual. Visual, at 2, the graph goes to infinity. So there's an infinite discontinuity there at that break. At this break, where these two pieces separate at 2, the graph is going to infinities. That's why it's an infinite discontinuity at 2. Infinite at 2 at x equals 2. And it's removable at x equals 7. So at 7, if you click it, you'd see it's just a little piece removed. It's a little dot. That's what we call removable. So those are your 3 problems there. And now we're going to start lesson 4.1, which is an introduction to trigonometry for pre-cal. It's right triangle trigonometry. By the way, you did cover this in geometry, but in calculus, we're going to really hit it hard. So that's what we're going to do today.